Assessing and controlling hazards on the worksite is at the core of every occupational health and safety program. This is true for residential, commercial, or industrial construction. While the purpose of hazard assessment is to identify and control hazards, there are two distinct approaches that you should be familiar with. The first approach is a formal hazard assessment, which is a deliberate, planned event that takes the entire organization into consideration and is based on each role and their associated tasks. The second approach is a site-specific or field-level assessment. This is an informal assessment that is performed either before work starts at a site or during work when conditions change. Each of these approaches might have a different title, like task hazard analysis or job safety assessment, but the principles are the same. A formal hazard assessment begins with an organizational chart that lists every position in the organization. Each position is analyzed to produce a list of tasks, and each task is evaluated for possible hazards. For example, an organization may have a variety of jobs or positions, including accountant, dispatcher, installer, manager, and so on. Some tasks will belong to more than one position, and some positions might overlap in the same organization. For instance, the accountant and the dispatcher both likely perform some of the same tasks: data entry, talking to clients on the phone, or filing. The hazard assessment process will still include these and all other tasks related to each position. Once you have a comprehensive list, you need to associate specific health or safety hazards with each task. Health hazards refer to anything that can harm someone's health, either in the short term or over a longer period. Safety hazards are those that pose an immediate threat of injury or damage and tend to receive more attention for that reason, but they should not be considered more important than health hazards. Hazards fall into four categories: physical, chemical, biological, and psychological. Some hazards might fall into more than one category. You can also categorize hazards by contributing factors: people, equipment, materials, or the environment. According to the Government of Alberta, a formal hazard assessment includes 9 steps. We have already mentioned Step 1, listing everyone's job within the organization. Step 2, listing all the tasks associated with each job. And Step 3, identifying both health and safety hazards of each task. Step 4 is to rank the identified hazards according to risk. Risk is the chance of injury, damage, or loss due to the hazard. There are many ways to measure it. It doesn't matter what method you use if you apply it consistently throughout the organization. One common method for measuring risk is to use a matrix of the severity of the hazard and the likelihood of it happening. Severity measures how serious the consequences could be. Likelihood measures how likely it is to happen. This matrix ranks severity and likelihood separately from 1 to 3, and then multiplies them. If both the severity and probability are 2, then the risk is 4. The higher the risk, the greater emphasis should be placed on prioritizing and controlling the hazards. Step 5 is to eliminate or control the hazard. Starting with those hazards that pose the highest risk according to the ranking from Step 4. Eliminating the hazard is always the first choice, removing tripping hazards from the worksite, or eliminating work at heights wherever possible. If eliminating the hazard is not an option, then the hazard must be controlled. Controlling hazards is done through 3 methods, and in the following order: engineering controls, administrative controls, and lastly, personal protective equipment. Often a combination of these 3 methods is required to control a hazard. Engineering controls control the hazard at the source, like installing ventilation for exhaust or using equipment guards on machinery. Administrative controls control the hazard through process, like implementing safe work practices, providing training, or limiting exposure to a hazardous environment. Personal protective equipment controls the hazard at the worker and is the last line of defense. Step 6 is to implement the controls. Step 7 is to communicate the hazards and controls. Step 8 is to monitor the effectiveness of the controls. Step 9 is to review and revise the hazard assessments at least annually or as conditions require. Formal hazard assessments are usually complex and take time to create and implement. Site-specific hazard assessments are more dynamic and take place on site before work starts or any time conditions change. They are used to identify hazards that occur due to changing conditions or when non-routine work is added to a worker's job. Any hazards identified by a site-specific hazard assessment must be dealt with immediately, and if that hazard is not included in the formal hazard assessment, it should be added. Some things that a site-specific hazard assessment might include are poor lighting, changing weather conditions, additional personnel on site, animals, underground utilities, and so on. Things that cannot be predicted in a formal assessment. Site-specific hazard assessments usually include 5 key steps. Step 1 is to figure out what tasks will occur on site on any given day. Step 2 is to identify the hazards. Step 3 is to eliminate or control the hazards. Step 4 is to communicate the hazards and to follow the controls. Step 5 is to repeat the process anytime there is a change in conditions to the work site. The methods for controlling identified hazards are the same as formal hazard assessments, with elimination being preferred. Where elimination is not possible, control the hazards through engineering controls, administrative controls, or by using personal protective equipment. Understanding the difference between a formal hazard assessment and a site-specific hazard assessment is vital to an effective hazard assessment system. Together, these two methods will help ensure that workers stay safe.